Some key concepts we must know for this lab are emission duration, which in this context, emission duration is the reference to the length of time that light is being emitted. This cannot be visualized in a single emission spectrum, but multiple can aid in determining if light emission is still occurring. If it is showing a peak, we can say that photons are still being emitted.
The research question presented to us was, what does emission duration depend on and not depend on? The hypothesis given is that the emission duration observed in chemiluminescent glow sticks is completely dependent on the energy input and completely independent of the emitting fluorescent dye. Let's find out if this is true. Spectra of both green and red dye. The first two were taken immediately after activating the dye, and the second two were after having the dye spend 1 minute in a hot water bath. If energy input does not affect emission intensity, after being placed in the water, the emission intensities will not change. But as we can see, the emission intensities for both dyes go up after being placed in the hot water bath because the activator alone is an energy input that excites the electrons. But the heat from the water acts as an additional energy input, therefore exciting the electrons at higher intensities. So we can say that energy input affects emission duration as they change after receiving additional energy. It can also be seen that the green dye stops emitting light before the red dye, despite them both having the same amount of dye and energy input. So we can say that emission duration is also dependent on the molecular composition of the different dyes. But why? Because green emits photons at higher intensities, meaning that it uses energy at a greater rate, thus resulting in a shorter emission. The large amount of possible reactions due to the more energy levels it has decreases the amount of time it takes to use up its energy input. The rate at which photons are emitted is directly proportional to the rate at which energy is consumed by the substance.
Therefore, we can say that emission duration is dependent on both the energy input and the molecular composition of the dye. This concept can be compared to a tale we all know, the tortoise and the hare. We all know that the hare, although he runs much faster, loses the race because he uses all of his energy and has to take a nap. The tortoise, although it can only walk slowly, has the endurance to outlast the hare and win the race. The duration of the green dye is represented by endurance of the tortoise and the hare. The duration of the hare was much shorter because he used all of his energy too quickly, just as the green dye emitted all of its energy much faster and therefore died faster. The duration of the red dye was much longer as it spread its energy out, just like the tortoise did.